Good afternoon. Good morning. My name is Jark, and sorry. It's a great honor to be here speaking as a closing keynote. And I'm currently leading Fluss team and Flink SQL team at Alibaba Cloud. And today I'm going to share about the Fluss. Fluss is a project we started since 2 years ago, and I'm going to walk through about the motivation and the key advantages and some use cases. So let's take a look at a typical data infrastructure in a company. So Kafka has been a backbone of nearly every streaming data infra out there. And then if you want to deliver some real-time insights, you need to process the streaming data and transform it with Apache Flink. And the transformed data, you may need to write it back to Kafka topics across multiple layers, like the bronze layer, silver layer, and the gold layer, which is also known as the Medallion architecture. But if you want to also perform a key lookup for enrichment, like join a dimension table using Flink. But Kafka doesn't support the KV lookups. So you can't use Kafka as a dimension table. So you end up to copy the Kafka data into a KV store, like Redis, just for that use case. And then if you want to query the Kafka topic, like to do some data exploration or data debug or for a real-time dashboard, Kafka is not queryable, so you have to copy the data again into an OLAP system, like Lakehouse. And if you want to build a data lakehouse for batch processing, okay, you have to copy the data again into an iceberg. So in the end, you are maintaining multiple data copies across many different systems. The Kafka, Redis, Lakehouse, Iceberg, it introduced a lot of costs and complexity, and creating data silos and hard to guarantee the data consistency. So I'm thinking that the Kafka topics at the end here actually provide zero business value because you can't query it, you can't look up, you can't even store long-term data in it. It's just used as an intermediate storage here, just like a black box. But is it a fault of Kafka? I don't think so. I think we are using Kafka in a wrong place. Kafka is very great for event-driven communication between microservices. It is also very great for high throughput log collection. But it is not good for analytics, like using with Flink, use as a dimension table, or integrate with Lakehouse. Because Kafka has no built-in schema. And the schema is the foundation for analytical optimizations. And Kafka doesn't support updates and is not queryable, which is very common in data warehouse. And Kafka is not optimized for long-term data, and it can only store very short-term data, which limits many analytical use cases like logistics. So we can see that Kafka is good for operational workloads, but it's bad for analytical workloads because Kafka is designed for events, not for analytics and AI. So it's not a fault of Kafka. It's ours that using Kafka in a wrong place. That's why we started the Fluss project since 2 years ago from scratch. Streaming storage for analytics and AI. So Fluss, in a short, this is an overview architecture of Fluss. So in a nutshell, Fluss is a streaming storage that supports sub-second streaming read and write. It is built as a columnar log streaming storage that's built on top of Apache Arrow So with Apache Arrow, which is a column format, we enable Fluss with a strong analytical capability. We support streaming, column pruning, and streaming partition pruning during a streaming read. So it can reduce a lot of network cost if you are performing a streaming read. And also, it supports us very high performance real-time updates and lookups. So you can use Fluss as a dimension table with Flink to perform lookup join. And the most important here is that Fluss supports Lakehouse as its tiered storage. That means you can use Fluss as a hot data, maintain hot data in Fluss local storage for fast access, and maintains cold data in Lakehouse for a low cost. And we use Lakehouse native format like Pymon, Iceberg, so you can use all the query engines to access the Lakehouse, access the code data directly, like using Spark, Trino, Starrocks. And the key feature here is called union read. A union read truly unifies the data streams and data lakehouse. Union read can read the combined data set of the hot data in Fluss and the cold data in Lakehouse. It first reads from the batch data and switch to the streaming data without any duplicates or missing records. And now, Flink is already supported the union read, and Starrocks is working in progress. And there is also a Starrocks session in this afternoon in Lakehouse track to share more details about the integration. So if you are interested, you can go and have a listen. So with Fluss, you can now get a real-time streaming Lakehouse for your unified data infra. So there is only one single data copy of your data, and your query engines can directly to query the single copy of data. So it provides the streaming read and write for Flink stream analytics. It provides the KV lookups for your dimension join. It provides the union read for OLAP queries. It provides the open lake format for batch processing. So compared to the previous beginning architecture, so you don't need to maintain multiple data copies across different systems. So it can reduce a lot of cost for you and simplify the data infra a lot. So real-time streaming Lakehouse is not a new Lakehouse. It is about to enhancing your existing Lakehouse with the streaming ability to enable the data sharing between data streams and data lakehouse. So in order to achieve this data sharing, Fluss maintains a tiering service that continuously converts Fluss data into the lakehouse format like Iceberg and Pymon. This is very similar to some database systems that have multiple data layers in the system. The hot data layer, warm layer, cold layer, and different layer is in different storage media and in different formats. The system will decide the data into which layer and guarantees the data consistency between the layers. And Fluss does this in a similar way, but just use the open lake format as the code layer. So the code data can be open and accessible by the Lakehouse ecosystem. For example, you can use your Spark, Trino to access the Lakehouse data directly. So this is a unified system that you can see the Fluss. It serves as the real-time data layer for Lakehouse to storing short-term and second-level latency data. And on the other hand, Lakehouse acts as a historical layer for the streams to storing long-term and minute-level data. And when you want to read a string, the Lakehouse provides the historical data for a fast catch-up. And when you are running batch analytics, the streams, the Fluss provides the latest fresh data from the past few minutes for the Lakehouse to make the Lakehouse analytics to be a truly real-time data analytics. Okay, so you may be wondering what if Fluss is so great, what is the production status and use cases? And I want to share that Fluss is already in production at Alibaba at a large scale. We are migrating our internal Kafka system to Fluss, especially for the real-time analytics use cases. And the adoption is growing as we expand the usage. Currently, Fluss is managing over 3 petabyte data size in total with clusters that handle an ingest throughput of 40 GB per second. And it also supports very high performance KV lookups up to 500,000 QPS on a single table. And the largest table contains over than 500 billion rows. Beyond the numbers, I want to share some use cases in Alibaba production. And the first use case is log collection and real-time analytics. At Taobao, which is the largest online shopping platform in China, we collect many different logs from apps and websites, including the click string, user behavior, order string, and so on. The log is very foundation for the downstream analytics and AI machine learning. But the team is facing large challenges when using Kafka because the data volume keep growing every year. And it is expensive to retain the data for 3 days. But the users want to retain more days than the 3 days. So it increases a lot of storage cost here. And meanwhile, the log is a foundation for many downstream jobs. It is very often that 1 write, 10 read for a single topic. And the cross-AZ traffic is also very expensive. So they are also facing a very high network cost. So after switching to Fluss, they leveraged the shared data of the streaming Lakehouse to keep the long-term data in Lakehouse so that they can reduce the data in Fluss by 30%. And Fluss is a columnar streaming format, streaming storage. So with the column pruning and the partition pruning, they can reduce a lot of network cost by avoid transferring the unnecessary columns or the unnecessary partitions. So in total, compared to the previous solution, the team reduced the total cost by 30% and reduced the read traffic by 70%. The second use case is delta join for large-scale streaming join. Streaming join is a very basic operation in Flink to join 2 streams for enrichment. It requires to store all the upstream data in Flink state. And it makes the Flink state very large, which introduces a lot of issues. But the Flink state is just, the join state is just a duplicate of the upstream data. And in our search and recommendation team, they need to join the page click string and the order string for the attribution analysis to know what did the user see that lead to a purchase. But the click string and the order string is super large, which lead to a 100 TB state size. And this makes the job very unstable and frequent checkpoint timeout. So we introduced the delta join in Flink, which leverages the Fluss key functionality like the streaming read, the changelog feed, and the Kiwi lookups. So delta join is, you can think delta join of a bidirectional lookup join, that when the data arrives from left string, it performs the Kiwi lookup on the right table on the join key. And when the data arrives from right string, it does the same thing on the left table. So it is stateless like a lookup join, but it guarantees the same semantic like the stream join without to maintain the large state in Flink job. So after this, switching to the delta join with Fluss, they completely eliminates the 100 TB state size. And this makes the job very stable. The checkpoint time reduced from 90 seconds to 1 second. And also it cuts the Flink resource usage by 85%. And beyond that, I think the major benefit is that the decoupling of state of the state and the job logic. So the changes to the Flink job is no longer to require a reprocess of the entire state. So it makes the Flink job updates more faster. And also users can inspect the join data directly in the Fluss. And the good news here is that we have already donated this delta join into Apache Flink, and it will be included in the upcoming 2.1 release. And if you are interested in this, there is a Flink 2.1 session in analytical check in this afternoon, where Lincoln will share more details about the design and the implementation of delta join. I'm also very excited about the future roadmap of Fluss. First, we will continue to enhance our streaming Lakehouse solution to support more open lake format like Iceberg and Data Lake. And we will support more query engines like Spark, Trino, Starworks. Meanwhile, we will support the multimodal AI, including support to real-time ingestion of the multimodal data, and also integrate with lines into our streaming Lakehouse. We will also plan to release a Python client with a deep integration with PyArrow, because we are using Arrow as our underlying log format. So it is very easy to integrate with PyArrow. Based on PyArrow, we will connect to the Python ecosystem like Pandas, Polars, DuckDB, and so on. So I want to share more thoughts behind the roadmap. In the AI era, I think we need to rethink what new demands and new challenges will the data infra face. I think there are around 3 key points here: the multimodal data, the streaming data, and the open data. The biggest difference between analytics and AI is that analytics works on structured data, but the AI works on the unstructured multimodal data, like text, images, audio, video. So the multimodal data will become more and more important in the data and the AI infra. And secondly, the AI and the agents will no longer rely on the yesterday's data. It requires the real-time streaming data to perform accurate and instant decisions. And lastly, the interoperability matters more than ever. just like analytics, AI also needs its open data format. So we believe that Lens has a big potential to become the open format for AI. So we will have a deep integration with Lens. So here comes the full picture of the upcoming release of the Fluss to involving Fluss beyond the analytics into a real-time pipeline for multimodal AI. So it will support to ingest multimodal data in real time and storing multimodal data in streaming format, and streaming converts them into Lens format. And from there, you can connect to the Lens ecosystem, including tools like Ray and PyTorch. And with the upcoming Fluss Python client, you can connect to the Python ecosystem like Pandas, Polars. And I think it will unlock a lot of use cases like real-time multimodal agent, real-time AI data lake, real-time feature engineering, and more. Okay, let's take a look back at the open source journey of Fluss. We first open sourced Live on Stage at Flink Forward Asia 2024 in Shanghai. And after that, we continually growing the community. And currently, we have 1,200 GitHub stars and more than 50 contributors across the world from companies like Alibaba, ByteDance, eBay, Ant Group, Xiaomi, and Tencent, and so on. The community also have a fast development path with three releases in 6 months. And half a year ago, we open sourced Fluss at Flink Forward Asia and committed to donate the Fluss to Apache Software Foundation in this year. So today at Flink Forward Asia 2025, we are very proud to announce that Alibaba has completed the donation of Fluss to Apache Software Foundation. And it is now an incubating project under ASF as Apache Fluss. And you can visit the new repository by simply replace the Alibaba with the Apache in the previous GitHub URL. Joining into Apache Software Foundation, I think it is a big milestone for Fluss community, and I think it is also a new beginning for Fluss open source journey to make Fluss more open, more community-driven, and vendor-neutral. And yeah, it is very welcome to join Fluss community for any contributions. Last but most importantly, we have launched the private preview of managed service for Apache Fluss incubating on Alibaba Cloud, and also now available in Singapore region. So feel free to scan the QR code to join the private preview program to explore the next generation streaming storage. Okay, that's all of my presentation. Thank you.